On July 27, 2025, Linus Torvalds officially merged Linux kernel 6.16 into the mainline tree, marking another 9-week milestone in the kernel's steady rhythm of innovation. This release delivers an array of under-the-hood enhancements and brand-new drivers that extend hardware support, boost performance, and add powerful capabilities for both desktop and server workloads. Under the banner of hardware enablement, one of the standout additions in 6.16 is initial support for NVIDIA's latest Hopper and Blackwell GPU architectures in the open-source nouveau driver. By including the PCI IDs for Hopper H100 and Blackwell B100/B200 cards, the kernel can now recognize and initialize these GPUs without relying on proprietary blobs, a crucial step toward full open-source acceleration on bleeding-edge AI and compute hardware. For Intel platforms, 6.16 introduces two high-impact features. The first is support for Intel's Advanced Performance Extensions, APX, paving the way for next-generation instruction sets that promise finer-grained performance tuning on modern CPUs. The second is initial compatibility with Intel Trusted Domain Extensions, TDX, enabling isolated execution environments that strengthen VM security by isolating guest workloads from the host hypervisor. Audio and networking also see notable upgrades. USB offload for audio devices lets compatible hardware handle audio data transfers with minimal CPU involvement, reducing overhead for high-fidelity workflows. On the networking side, Linux 6.16 can now stream TCP payloads directly from device-managed buffers, DMABUF to the wire via a zero-copy transmit path, which can dramatically improve throughput for GPU-centric applications that push large volumes of data across the network. File systems receive care as well. XFS gains support for large atomic writes, ensuring multi-block operations can commit safely in a single transaction. Meanwhile, ext4 benefits from large folio support, which lets the file system map big memory pages to regular files for more efficient I/O on huge datasets. And for next-generation embedded and big data storage, the bigalloc driver adds multi-fsblock atomic writes, solidifying consistency guarantees on specialized block-packed file systems. Beyond these headline features, 6.16 weaves in a host of smaller but impactful changes. Futex system calls now include per-process hash tables to speed up thread synchronization. Core dumps can be dispatched over AF_UNIX sockets for streamlined crash reporting. And an automatic weighted interleaved memory allocation policy adapts to diverse DRAM configurations without manual tuning. Kernel maintainers have also added a convenient system service for CPU power, making CPU frequency tuning available out of the box. NVIDIA users gain an ACPI-bound HD audio control interface. Intel platforms pick up auto counter reload, ACR support, and fscrypt welcomes hardware-wrapped keys for tighter file encryption integration. On the acceleration front, EROFS, Enhanced Read-Only File System, now taps Intel's Quick Assist technology, QAT, to offload deflate decompression, speeding up compressed reads. Tegra 264 support lands in the ADMA controller driver, AMD ACP7.X, and additional Intel. AVS platforms broaden audio codec support, and a slew of new drivers covers everything from Realtek's 10 gigabit Ethernet controllers to Apple's M2 Pro/Max/Ultra PCIe interface. Last but not least, Linux 6.16 flips the switch on 5-level paging by default, expanding the addressable virtual memory space from 256 terabytes to a staggering 128 petabytes on supported architectures. A forward-looking change as datasets and in-memory databases continue to grow. With kernel 6.16 released, the merge window for 6.17 opens immediately. You can test the first release candidate on August 10, 2025, but most users will want to wait for this new kernel to filter through distribution repositories before upgrading their production systems. Until then, explore the complete changelog on kernel.org and keep an eye on what's coming next in the Linux universe.